Hello students, today our topic is Python programming and in this lecture we are going to discuss some question answer related to bitwise operator used in Python programming. So as we know that these are the bitwise operator, this is called bitwise AND, this is called bitwise OR, this is bitwise XOR, bitwise NOT is a symbol of bitwise NOT. Okay, so first of all I will show you the truth table of all these operator first. So let us do it by one by one. First of all, value of A and B. If there are two inputs A and B and we have to find A XOR B, A and B, sorry, A and B first, then first of all write all possible input combinations. And all possible input combination we can write it as first time just write first 2 times 0, then 2 times 1, then 0 1 0 1 at alternate places. So these are the four possible combinations 0 0 0 1 1 0 1 1. Okay. Now according to the definition of the AND, if both input are 1, then output is 1, otherwise output is 0. So this is the truth table of AND. Okay, this is the truth table of AND. Remember the definition: when both inputs, or if more than one inputs are there, then we can say that if all inputs are found to be 1, then output is 1, otherwise output is 0. So you can see here in first case 0 0 both inputs are 0, then output is of course 0. In second case, one input is 0, second is one input is 0, second input is 1, so output is 0 again. In third case, first input is 1 and second input is 0, so output is 0 again. But in last case, both input are found to be 1, that means output is 1 in this case. So this is the truth table of bitwise AND. Okay, now if you want to find out the truth table of bitwise OR, then just write all input possible combination. Again these are 0 0 0 1 1 0 and 1 1. And now in this case we have to find out the A or B, that is a symbol of OR. So according to the definition the OR, if first value, if any value is found to be 1, any at least one value is found to be 1, that is the correct definition, at least one value is found to be 1, then output is 1, otherwise output is 0. So in first case you can easily see here that both input are found to be 0, then output is 0 again. In second case, second value is 1, of course the output is 1. In third case, first value is 1, then output is 1. In fifth case, both values are 1, then output is 1 again. So that is the truth table of bitwise OR. Okay, now let us take the truth table of bitwise XOR. Bitwise XOR, according to the definition of the bitwise XOR, if all inputs are found to be same, then or both input are found to be same, then output is 0, otherwise output is 1. So in first case you can easily see here that 0 0 is there, it means output is 0. In last case you can easily see here that 1 1 is there, both values are found to be same again, that means 0 is again the output, and in remaining cases output is 1. So that is the truth table of XOR. Okay, as far as not is concerned, bitwise not is concerned, actually not basically operator negate the value. If input is 0, then after the negation or after the bitwise not operator, 1 is to be found, and if 1 is there, then after not operation, bitwise not operation, 0 is the answer. Okay, now let us do some more bitwise operator. Okay, left shift and right shift, left shift and right shift. So this is the left shift. And how many places it should be shifted? It should be shifted two places. So whatever is the value of a, first of all we have to convert this value into its binary form. For example, if number is like that 0010 0011, then after shifting it two places it is 1100. That is the output. If that is the value of a, then that is the value after we get left shift two places to its left. Okay. Right shift is just opposite to that operation. Again, for example, if this is the value of b and we have to shift it right, and we have to find b right shift 2, then we get the number 0011, means same number which is the number before left shift. Okay, 0011. So these are the left shift and right shift operator. Or we can say that if any digit or number is shifted to its left at certain number of places, and again it is shifted to its right again that certain number of digits, then we get that original number. Okay, so these are the left shift and right shift operation. These are the basically in left shift and right shift, digit is shifted to its left or its right at a given number of places as given in the question. In this question 2 is given, so it is shifted to its two places to its left if a left shift operator is there, and in case of right shift operator it is shifted to two places to its right. Okay, next is, now I think you have a good idea, you have a good idea of all the bitwise operator. Now, the one thing that is most common in all questions is the number system conversion. So I just give you a brief introduction of different number systems. So basically, there are four types of number systems. These are decimal. Decimal in the number system in which we calculate in our real life. Second is binary number system. In decimal number system, these are the digits that we used: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 9 is not 9 up to 9, sorry. 10 is not the part of decimal number system because any number is formed by using these 10 digits. Okay, and in mathematics we just represent decimal number system by giving by just writing in subscript 10. In Python programming, decimal number system is considered as by default. Okay, if no number system is mentioned, for example, in binary number system, 0x 0 b is there. For hexadecimal, 0x is there. That is the representation. If no representation is there, then by default it is considered as a decimal number system, or value is considered as an integer value, we can say that. So that is decimal number system. Second number system that is used is binary number system. Binary number system is that number system in which our machine or computer works. It is a number system in which there is only two digits, which we call as a bits, and these two bits are 0 and 1. So second is binary number system, and only two bits are used, that is 0 and 1. Okay, so any number which is formed by using these number is basically called a binary number. In subscript we use 2 to represent it in mathematics, and in Python programming we just write 0b to represent that it is a binary number. Because when you see a number, you cannot say that it is a binary or it is a decimal number system generally. So there is basically a representation which tells you which kind of number is this. So for example, if I just write 1001, then this is a binary number. And one thing always we remember, that if we add 0 before any number, then it will makes no effect on the magnitude of that number, whether the number is a binary or whether the number is basically decimal or octal or hexadecimal. Okay, Next number system is octal number system. Third number system is octal number system. In octal number system, as the name suggests, 8 digits are used, and these digits are 0, 1, 2, 3, 4, 5, 6, and 7. Okay. In hexadecimal number system, so any number which is a combination of all these digits is basically a octal number system. For example, 57 is represented mathematics just like that. This is an octal number system. In Python programming, octal number system is represent, there is a prefix oo, o0, 0o, sorry, 0o, which represent that it is a octal number system. Now let us talk about hexadecimal number system, which is the fourth one. Hexadecimal number system. Hexadecimal. So in hexadecimal number system, basically, wait a minute. In hexadecimal number system, basically hex means 6 and decimal means 10. So there are 16 bits or 16 digits or character that are used in hexadecimal representation, and these are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and for 10 we write A, for 11 we write B, for 12 we write C, for 13 we write D, for 14 we write E, and for 15 we write F. Okay, so in mathematics we generally write hexadecimal number like that: 5, 1, A, and in subscript we write 16 to represent that it is a hexadecimal number. In Python programming we write ox as a prefix before any number, and it is considered as a hexadecimal number system. Now that representation is very important, because in certain numbers uh, we cannot say that it is a hexadecimal or it is an octal or it is a uh, binary number. For example, if I just write 1 1, then it may be a octal number, it may be a hexadecimal, it may be a decimal, or it may be a binary number. Okay, so until and unless we don't write a value in subscript, we cannot say that what kind of number is this. So for example, if you just write 2, that means it is a binary number. So this is the concept of mathematics. But in Python programming language, we basically add prefix before any number, which gives you what kind of this number is, whether it is a integer number, whether it is a octal number, whether it is a hexadecimal number. The prefix tells you what kind of number is this. And if we don't mention any prefix, then by default it is considered as a decimal number system. Okay. Now the second question. Now the second question, which is very important, and this question is how we can convert one number system into another. How we can convert one number system into another. This is a very important question. So first of all, since binary number system is very important, so we should learn how to calculate binary into decimal, binary into decimal, binary into octal, and binary into hexadecimal. Binary to hexadecimal. Okay. So for example, if there is a number like that, let's take a binary number, and first of all we have to just give that I just want to show you how to convert binary to decimal. So let us take an example. For example, there is a number 1010, that is a binary number, and we have to convert this number into its decimal equivalent. Okay, then how can we perform it? So write the number in different, make different boxes. For example, number is 1010, 1010. Then write 2 power 0, 2 power 1 in increasing order from left to right, from right to left, 2 power 2, 2 power 3, and multiply these number, and after that add all these numbers. So first of all we get 1 into 2 power 3, then second 0 into 2 power 2, then 1 into 2 power 1, then 0 into 2 power 0. Okay, so we get 8 plus 0 plus 2 plus 0. So we get a number that is equal to 10. So 10 is the binary equivalent of this number. I think it is clear to all of you. Okay, if number is in fractional part, uh, number contain its fractional part, then how we can convert this into binary number, I will show you. For example, if number is like that, 10.11, this is a binary number, and it contains as a decimal also. So to convert this number, again we have to follow the same procedure with little bit changes. 10 and write decimal here, and after that 11. So before decimal you can multiply each bit by 2 power, 2 power 0, 2 power 1, increasing power of 2, in an increasing way. So first number is multiplied by 2 power 0, second number is multiplied by 2 power 1, and after the decimal we multiply each number by in an each number by 2 power, but power is now in power is mentioned as a negative number. Okay, so first number is multiplied by 2 power minus 1, second number is multiplied by 2 power minus 2, and up to so on. And again multiply these odd two numbers and then add the final result. So we get in this case 2 power 1 into 1 plus 2 power 0 into 0 plus 2 power minus 1 means 1 by 2 means 0.5, and 2 power minus 2 means 1 by 4 means 0.25. So we get the number which is equal to 2.75. So that is the decimal equivalent of that number. Okay, okay, now I think it's clear to all of you. Now, so this is the first way how to convert binary number system into in, into an into decimal number system. Now, to convert binary number system into octal, or to convert octal into binary, we should remember a table. There is a table, so no method is used, directly a table is implemented like that. So first of all octal numbers are given, and then write just its binary equivalent. So the numbers, all octal numbers start from 0. First number is 0, then 1, then 2, then after 3, 4, 5, 6, and at last 7. Then to write its binary equivalent, just write 4 times 0 and 4 times 1, and then 2 times 0, 2 times 1, then 0101 continuously. So we get binary equivalent of all octal numbers. Okay. Now, for example, if you want to find out, there is a suppose there is an octal number 75, and okay, I will show you 75.2. That is an octal number, and we have to find out its binary equivalent. Then just see the binary equivalent of 7. Binary equivalent of 7 is 111, so write 111. Then write binary equivalent of 5. Binary equivalent of 5 is 101, 101. Then write decimal as it is, and then write binary equivalent of 2. Binary equivalent of 2, you can easily see that is 010, 010. So that is the binary equivalent of that number. Okay. And one thing should be remember that if we add 0 before any number, okay, then it will makes no effect. For example, if we write this number as this, then magnitude of both are same, and we can also add 0 just after the decimal like that. Now that will make no effect on the magnitude of that number. I think it is clear to all of you how to calculate binary, um, how to calculate a binary number of a given octal number, and you can also calculate a binary to binary to octal number. For example, if there is a question like that, there is a binary number, and you want if you want to convert it into octal number system. For example, question is like that, 1011.1. This is a binary number, and if you want to convert it into in octal form, then first of all, make sure that there is a pair, there is a group of 3 bits, there is a group of 3 bits. So you can easily see here that 011 is there. Okay, that's make no problem, but only a single bit is here. So add 0 before this, so you can just write it as 001 and then 011, and again single bit is there, so after the decimal, so again add 0 just after that, and now make a group of 3 bits and write corresponding octal number which represent these bits. So 001, so code of 001 is 1, so write 1 here. Then 011, code of 011 is you can easily see here that code of 011 is 3, so write 3 here. And code of 100 is 4, so write 4 here. So that is the octal equivalent of this number. I think it is clear to all of you. Okay, now let us talk about binary to hexadecimal and hexadecimal to binary representation. So as we know that in hexadecimal representation there are 16 digits or symbol that are used. So again we have to make a table to represent a binary number equivalent to a hexadecimal number. So first of all, just write hexadecimal equivalent, then binary equivalent. So make a table. I think space is not sufficient here, so I just break the table into 2 parts. So write all the hexadecimal number 0, 1, then 2, then 3, 4, 5, 6, and then 7, and then 8, then 9, and we write A in place of 10, then B, then C, then D, then E, and at last F, which represent 15. Okay, then write 8 times 0 and then 8 times 1. Okay, just like that. Then 4 times 0, 4 times 1. then 2 times 0, 2 times 1. Okay, I think there is a mistake in here. No, 0 0 1 1 0 0 1 1 0 0 0 0 1 1 0 0 1 1. Okay, and at last 0 1 0 1 in an alternative way, 0 1, then 0 1, then 0 1, then 0 1, then 0 1, 0 1, 0 1, 0. So that is the truth table of hexadecimal to binary. Now if you want to convert a hexadecimal into binary number system, for example, we have a number like that 1 2 3 point B, and we have to convert this hexadecimal number into binary number system. Then see the code of 1. So the code of 1 was 0001, so we can just write it as 1 because 001 is equivalent to 1. Okay, okay, one number is 123 point B. This is a hexadecimal number and we have to convert this into binary equivalent. So just write the code of 1. Code of 1 is 0001, 0001. Then write the code of 2. Code of 2 is 0011, 0010, 0010. Now just write the code of 3. Binary equivalent of 3 is 0011, 0011. Then write decimal as it is. Then write the code of B. Code of B, you can easily see that 1011, 1011. So that is the binary equivalent, and we can write it also as just remove these all unnecessary zeros. So we can write it as 100100011 point 101. This is the binary equivalent of this number. Okay, now if you want to convert a binary number into a hexadecimal number, then the process is same as we follow in the octal to binary conversion, but here we make a group of 4 bits. For example, there is a number like that 101.11011. So make a group. First of all, here 3 bits are there, so we have to add at least 10 to make a 4 4 bit group. Then after decimal again make 4 bit group 1101. Here only single one is there, so add 30. Now just write the equivalent hexadecimal code. For example, 0101. So just see the code of 0101. 0101 is represented by 5, so just write 5 here. Okay, then write decimal as it is, and then 1101. So 1101, code of 1101 is D, so just write D here. Then 1000, code of 1000 is 8, so write 8 here. So 5.D8 is the correct answer. This is the binary equivalent of this hexadecimal representation. So in this lecture, we basically focus about different bitwise operator, their truth table, and we learn how to calculate binary equivalent of decimal of octal number system as well as in hexadecimal number system. I hope now you are able to understand all this concept and you can easily apply this concept into this numerical. So thanks for watching this video.